Navjot Singh Babra, and today I'm going to present my ETY presentation for circuit B by using the superposition theorem. So let's check our circuit. Here we're going to look in our circuit B, which having the two sources. One is the source 1 having the current source 2 is a voltage source, and having the 4 resistor. So let's check our circuit. So this is the circuit having the source 1 2.4 milliamp, source 2 is 8 volt, and we having the value for resistor. So in the superposition theorem, first we remove the source 2 and we taking the source 1, and we just see that these two resistors are in parallel and these two resistors are in parallel, so we just make it equivalent and we got our RT. This is our equivalent circuit. So see, here we go. So we have the RT and we have find VT here, so which is the 7.44 volt, and we know that the current is same. So what we're gonna do, if we find the voltage across each resistor, that's the voltage across these 4 resistors. So 4.32 volt for R equivalent A is R1 R2, and R equivalent 2 voltage is for R3 R4. So we having the voltages, we having the R resistor values, so we're going to find easily the current by using the Ohm's law. Here we go, we find the I1, I2, I3, I4, and we got our value for the P, just V into I, and that's our P1, P2 and P3, which is the power. Let's look in our second circuit. There we go. So this is our figure B. In figure B, we remove our source 1 and we just considering our source 2, and we having the voltage here. First we make it in the equivalent and we find the RT, IT and VT. We have the VT already. So for figure B, we know we have a look here. So if we see that these two resistors are in parallel, so we can't find the voltages for these two, but if we have the voltage for these two, the voltage is now same here. So we find the current, and when we find the current for R equivalent A is same here, and the current for R equivalent B is same here. Here we go, we did here, we find the current, and just applying the Ohm's law, we got the voltages for each resistor just by I1 into R1, I2 into R2, I3 into R3, and same we did for the power. Here we go, we have the we have the values for power, values for V. Now we have to get into our final circuit, where we considering the two sources, and this is looking tidy. Just for considering the directions, here we go. So this is the directions. So we send there that the current is coming from here, and for this resistor the current is and the voltage source, they are opposing each other, their direction, and same for R3. But for R1 R2 we see that the voltages and the current, they are going in the same direction for these two resistors. So we're going to add voltages, current and P for these, and we're going to subtract for these two resistors. We did here. So the voltages in the final circuit, V2, V3 and V4. Here we go. So now we got on our figure A, figure B, where we having the values for figure A, figure B, and this is the value for figure B, which is our final circuit. So this is the values for final circuit, and this is our V, I, R value. Let's check our OCAD. Here we go. So this is our OCAD, where we first considering the current source, and we getting the same value for R and V. Let's check the considering just removing the current source, and we just having the voltage source here, and we getting the same value for our V and I. Here we having the our circuit, which having the both current source and the voltage source, and this is our values we are just found in our calculations. So our superposition work. Thank you for watching this video. My name is Navjot Singh Babra.